Hi, Caitlin. Okay, so let's take a look at this problem you sent me. The properties can definitely be tricky, so I absolutely understand why you reached out. And I think once we talk through them a little bit, I think it will help a lot. Okay, so if we look at this problem right here, it says what property of the whole numbers justifies each step in this calculation, right? So we've got this 17 times 7. And then in the very first line, they've just decomposed the 17 into 10 plus 7 and then multiplied it by 7, which we can do by properties of multiplication. So if we look at this very first step, it says what property of the whole numbers justifies this second step. So to go from this first line where it says 17 times 7 equals 10 plus 7 in parentheses times 7, down to the second line, we have 7 times parentheses 10 plus 7. All we've done to go from the first line to the second right here, let me zoom in a little bit too, so it's not letting me. There we go. Okay, so all we've done to go from here to here, sorry, it's not letting me highlight the first line. I hope that probably looks kind of crazy on your end. So to go from this first line to here, all we've done is swapped the 10 plus 7 on the left side and the 7 on the right. All we've done is swap them. And whenever you swap, right, so we've got two things being multiplied together, two factors being multiplied together, that's called the commutative property. That's how it's defined. The commutative property says that it doesn't matter what order we multiply our factors in. So if we multiply if 10 plus 7 is our first factor and 7 is our second, we can swap them, and 7 can become our first factor and 10 plus 7 can become our second factor. So order of how you multiply factors doesn't matter. To simplify it a little bit, we know that 5 times 2 is 10, right? Well, if we switch the 5 and the 2 and it becomes 2 times 5 now, that still equals 10. That's the commutative property. You can swap around the order of the factors and you still get the same answer. So that's why we could swap this 10 plus 7 from being the first factor to down here being the second, and why we could take the 7 from being the second factor and swap it to being the first. That's the commutative property. So that's part A. Part B says, let me move myself out of the way here. Part B says what property of the whole numbers justifies the third step. So if we look down here, okay, at this third step, so now we've started with 7 times quantity, 10 plus 7, and we've changed that to be 7 times 10 plus 7 times 7. So that means that we've taken, in the second step where it says 7 times 10 plus 7, we've taken that first factor of 7 and we've distributed it through the parentheses. So we did 7 times 10, which you see right here, plus 7 times 7, which you see right here. And so that has a name. It's called the distributive property. We're distributing that 7 to each of the numbers in those parentheses. So that's what distribution is. It just means you take what's on the outside. So we're going to take this 7 right here and we're going to distribute it through to both numbers on the inside of the parentheses. Right? Those parentheses tell us, oh, we have to distribute. This 10 plus 7 is one term, so we can't just multiply 7 times 10. We're missing a piece of that term. That started as a 17. We need to make sure we multiply that 7 by the entire 17. So we need to multiply it by the 10 and by the 7. We need 17 groups of 7. So this, when we distribute it through to the 10, that gives us our 10 groups of 7. And then when we distribute it through to the 7, that gives us our 7 groups of 7, making 17 groups of 7 in all, which is what we started with, right? We needed 17 groups of 7. And so that's the distributive property. It basically just says, like, if you have something in parentheses, you have to distribute that factor through to both numbers. Otherwise, you're going to lose some of those groups, right? We want 17 groups of 7, so we need the 10 groups of 7 and the 7 groups of 7. So we need to multiply that 7 by both factors. So that's the distributive property. The associative property just means that has a lot to do with parentheses. So when we have parentheses around something, let me see if there's an example of it in here. Oh, sorry, hold on. Somebody's coming into my room. I'm at work right now. It's our last day. It's our teacher cleanup day, so I'm cleaning up my room. But somebody's at the door. Give me 1 second. I'll be right back. Okay, sorry. So the associative property says that when we have the order, just like the commutative property tells you the order of numbers, the order of factors doesn't matter when you have two factors, right? So 2 times 5 is the same as 5 times 2. They can commute. Think of commuting as moving, right? When you commute to work, you're moving. You can move those factors around. You can commute them. Associative property of multiplication is almost identical, only it says that if you have 3 or more factors, or yes, 3 or more, it doesn't matter the order that you multiply them in. And so, for example, we could, if we had like 7 times 4 times 3, we could multiply the 7 times 4 first and then multiply that product by 3. Or we could multiply the 4 times 3 first and then multiply that by 7. So again, order doesn't matter. We can multiply those 3 factors in any order we want and we'll get the same answer. We'll get the same product. And typically you'll see parentheses around whichever ones you want to multiply first. So a lot of times the associative property will involve parentheses, but it's just like the commutative property in the sense that you can, if you have 3 or more factors being multiplied together, you can multiply them in any order and it will not change the product. That's the associative property. The closure property of multiplication says that if I perform the operation of multiplication on 2 of the same kind of number, I will get that same type of number as my answer. So let me put some context to that. We have been looking at whole numbers in this unit, right? 0, 1, 2, 3, 4, 5, on and on and on and on, all the way up to infinity. Not including infinity though. So 0, 1, 2, 3, any non-negative whole number that's not a fraction or decimal. So if we take any 2 whole numbers and multiply them together, do we get a whole number as our answer? So if I picked any 2 whole numbers at random, so if I picked 125 and 2 and I multiplied them together, right? 125 times 2 is 250. Do I get a whole number as my answer? Is 250 a whole number? It is, right? So whole numbers are closed under multiplication because I can pick any 2 whole numbers, multiply them together, and I will get a whole number as my answer. So we would say that whole numbers are closed under multiplication. And so we can look at all different kinds of numbers. We can look at even numbers, for example. So if I had 2 even numbers, 2 and 4, we know those numbers are even. If I multiply them together, do I get an even number out? So 2 times 4 is 8. I do, right? And I would do a few examples. What if I multiplied another even number? Let's go a little bit higher. 10 times 10. 10 times 10 is 100. Do I get another even number out? I do. So even numbers are closed under multiplication because if I pick 2 even numbers and multiply them together, I get an even number out. Let's try odd numbers. 3 times 5. 3 is odd, 5 is odd. If I multiply them together, do I get another odd number? I do, right? 3 times 5 is 15. Let's try another one. How about 7 times, I want to pick a higher one, 9. 7 times 9 is what? 9, 18, 27, 36, 45, 54, 63. Do I get another odd number out? I do. So I multiply 2 odd numbers together, I get an odd number for my answer. Odd numbers are closed under multiplication. Okay, so if I pick 2 of those numbers, perform the operation of multiplication on them, do I get that type of number out? If I do, it's closed. That's what closure means. If I pick 2 of those kinds of numbers, perform the operation, do I get that kind of number out? If that same kind of number out, I do, then it's closed. If I don't, then it would not be closed under multiplication. And closure carries through to all of the operations. Some types of numbers are closed under multiplication, but they aren't closed under addition. Like the example we just did with odd numbers, right? We picked 2 odd numbers, we multiplied them together, and we got an odd number out. If we now look at the operation of addition, if we add 2 numbers together, like 3 and 5, 3 plus 5 is 8, which is an even number. So odd numbers are not closed under the operation of addition. So that's an example of where closure doesn't happen for that operation. So you can apply closure to any operation. The question you always want to be asking yourself is, if I perform that operation on on 2 of those numbers? Do I get that same kind of number out? If I do, it's closed under that operation. If I don't, it's not closed under that operation. So I hope that helps a little bit. If it doesn't, let me know. We can definitely meet and go through more examples. I'd be happy to do that. Just shoot me some times that work for your schedule. Evenings tend to work better for me, sometimes like mid-afternoons, just because of my kids. Now I'm going to be home with them all the time. So just because of their schedule, but I can always do early mornings too. So anyway, I know you have 3 little kids too, so you probably have just as busy a schedule, if not busier. So let me know, but hopefully this helped a little bit. If it didn't, just please keep reaching out. I'm really glad that you do. All right, bye, Caitlin.